Here's another example of an exoplanet orbiting another star. This is the exoplanet HD40307G. When they letter these things, HD40307A would be the star that it orbits. And then B, C, D, E, F, and G are the planets that orbit that star. So that means that this particular planet is the star that or rather the planet that is farthest from the star that it is orbiting. This particular star is 42 light years away from our sun. Its orbital period is 197.8 days, which turns out to be 17,089,920 seconds. Its orbital radius is 89,800,000 kilometers, which turns out to be 8.98 times 10 to the 7th kilometers. Add 3 to that exponent, and that converts the number of kilometers into meters. So we know that the radius is 8.98 times 10 to the 10th meters. From our last calculation, we calculated that 4 pi squared over g was 5.9188 times 10 to the 11th, and we can use that in this calculation as well. So we're calculating the mass of the star HD 40307A. So M1 would be equal to 5.9188, let me move this, times 10 to the 11th. And we have a delivery. Okay, and then R cubed is going to be 8.98 times 10 to the 10th power raised to the 3rd power. And then we're dividing by t squared, which is 17,089,920, and we'll square that. Okay, so let's start this off. We're going to start off by cubing 8.98 times 10 to the 10th. So we go 8.98 exponent 10, y to the x, 3, okay, and that is 8.98 times 10 to the 10th cubed, right? And then we're going to divide that by, and we can use parentheses here, 17,089,920 squared, close the parentheses, equals, and so that was 8.98 times 10 to the 10th quantity cubed divided by 17,089,920 squared. Okay, so we have all of that. Now we're going to multiply that by 5.9188 exp11. And that means that M1 is 1.4675 times 10 to the 30th power kilograms. Okay, and compare that to the mass of our sun, which was 1.989 times 10 to the 30th kilograms. Okay, now we can divide that since we have this number on the calculator still, so divided by 1.989 exp30, and that means that it is 73.8% the mass of our sun. And so the question would be, how does that compare to what we would find on, say, Wikipedia or some other astronomy website about the mass? And Wikipedia says that the mass of that star is 75% of the mass of our sun, so we're actually pretty close. We got 73.78 or 73.8% of the mass of the sun. So that means that we're pretty close.